and today we are going to be wiring up this endoskeleton creature thing I created. I know some of you followed this along and saw bits and pieces of it coming together, but when you put it together, this is kind of how it wound up. Now, a couple things I need to fix and change, but for the most part, you got the idea of what's happening. And I see a couple of you guys already joining the stream. And so, hi, Carl. I hope your brother is doing well. David Roach, of course, he's going to be invaluable because he always keeps an eye on my electronics. So hopefully you'll steer me right here because we're going to be adding servos and the whatnot. And the big goal today is that if we don't grenade anything, we have been super successful. And we have Brian Palmer, hi, and Ernesto is back. Always good tips from Ernesto too. So what you probably see now is this kind of blinky thing going on. And I have this Arduino board here connected to this breadboard. And Wrench Army members, we actually prototyped this together. So to catch everybody up, I'll go ahead and go through it. So let me switch cams. And one notice, today we have something special going on. As some of you know, I do also record all these for VR in 3D. And for projects where you make a lot of duplicates, well then it gives you a chance to shoot things with each camera. But for processes where it's a one-shot deal, I gotta run all the cameras. So I got him kind of sitting here where you guys can't see him. So let me get him fired up and get him recording. And I will go ahead and do this, and just to kind of give you guys an idea, this is in blurry vision, but this is a 180 VR camera, and what it allows you to do is actually see almost my entire shop. It's 180 versus 360, but the nice thing is that it is in 3D. So you can watch this on Oculus, you can watch it on Facebook and on YouTube. I release it all on those channels. You don't have to have one of those VR glasses or headsets to watch, but it sure is cool because you can see everything in 3D like I'm coming out at you. All right, enough of that. Back to the project. So I'm going to take it, rewind us a little bit in case you kind of haven't been up to what I've been up to. And what we're doing is actually doing something very good for the benefit of all mankind. And we're going to answer the question of, is it really true that who smelt it is the one who really dealt it? Or the one who denied it was the one who really supplied it? And we are going to do this in the most scientific way that, I can think of doing it. So, Carl James is saying that he'll tell his brother that I said hi, so that's awesome. Charles has also joined. He is from Levittown, and he says hi, and Conrad says hi. So keep posting your questions. I'll get to as many of them as possible. Some I may be able to answer, some I may not, and we'll discover together. But anyways, the project here is to create a fart detector. And in our first stream, I tried to pretty up the name and call it a flatuosity meter. But all in all, it is a fart detector. So what we did is create just kind of the mechanics and electronics of how this was going to work. And I thought it would be really cool to try and disguise this in something. So it's not like you're walking around with an obvious meter to see who is, the culprit of all the stinkiness. What if you can have someone that, or something that no one would ever suspect is actually fart detector? I thought about cool lunchboxes, if you're at work, no one would suspect, hiding it in a briefcase. But then I thought, who would suspect little FART-A-TUCHUS here would be sniffing around for those noxious gases? So the first thing that I did here is hollow him out. And I figured we're going to somehow disguise this device inside him. And for our prototype, I went ahead and wired these LEDs for its lights. Now it'll have two of each, of course. We just did one just to see if we can get the darn thing working, right? And so here are his little eyes. And the reason I chose FART-A-TUCHUS here is because my dog had already kind of done a number. He ripped his eyeballs out. His little feet are, look, its stuffing's already coming out of his feet. So he was pretty much half committed from the get-go. So first steps is just to kind of open it up or open him up and see how much room I got dealing with. So I went through the derriere, and that is like the theme of this entire project, is going in through the derriere. So if you like butt and fart jokes, you have joined the right stream. If you're squeamish about that, well, I'm sorry, but I love derriere jokes. They make me laugh. So we do have a decent amount of room, but one of the things I did not take into account, and see my dog, he is like prime suspect because he always frames me for these things. So FART-A-TUCHUS will be able to clear my name. All right, so we have a couple more people joining. Don, Corey from Canada, wow, Sank and Joe S. And he's accusing me. He says like, oh yeah, sure, you blame the dog. I do, because it's true. So I am the one who smelt it, but I didn't dealt it, right? I didn't deal it. So we're gonna find out, right? So with our FART-A-TUCHUS, one of the things that made this project a challenge is that he is angled. And I will switch here for you guys to see. He sits at an angled position versus a teddy bear that sits in an upright position. So were I to do this again, I would highly recommend an upright type of animal because this kind of made it rather difficult. And then last minute, I decided to add a feature that I thought would be cool. Like, what if when the sensor here detects a fart, the nose twitches like this? And I thought that would be really cool, and that's where our servo comes into play. Well, you can't just stick a servo in a soft thing, because as it tries to move, it's actually just gonna, like, you know, make the head just kind of do weird things, and it's not gonna look really realistic. So we actually have to build some kind of endoskeleton, almost like a puppeteering type of thing. So this is what I came up with. And of course, these are its eyes. And I do have somewhere around here in my messy workspace, that's why I can't ever find anything, and I lose sockets and all that. But I bought these cool glass eyes that'll go on the outside here, and then I'm gonna stick the little LEDs through these PVC pipes, and that'll glow the eyes the different colors. You know, green for it's safe, and then yellow for, you know, something's going on, you still have time to run, and then red is like high alert. This is like really, really dangerous stuff going on. And here you see the servo sitting on its head, and I can give you guys a much better view here, this little servo. Now I will, before we go any further, you for real world workers out there, you might want to avert your eyes, because some of this workmanship is, well, you can't unsee it. I'm gonna leave it to that. So here's our servo, and the idea here is that I'm gonna put like a toothpick, or probably double up toothpicks. You can always see, already see I kind of have a hook there for it, and it's gonna go like this. And that's what's going to move our nose. So eyes, nose taken care of. And then I thought it'd be a great idea of, well, the last thing you want to do is walk up to the person and just kind of like, you know, we'll put the sensor on the bottom end, because we need to be able to see the eyes. So we'll position them like this. Well, it's kind of weird to go up to someone and just kind of like stick the butt against their butt, you know, and, you know, they're gonna know what you're up to. So I thought it'd be kind of neat to have some kind of extension device. So you can be holding FART-A-TUCHUS, and with this lever here, just extend the sensor. It'll do the sensing without you having to get all that close. Now, I would have loved to make it super long, and I started making this out of toothpicks. And in retrospect, yeah, I probably should have like upgraded and done it with metal, because it is quite floppy, as you can see. It's a little sturdier than I imagined it would be, but you know, it gets the job done. And of course, the longer that it extends, the more friction points you get with your scissor lift type of situation, and it becomes really hard to pull in and out. So that's why I kind of like looped it up like this, just to kind of like get it going. And these right here, I thought I'd leave them hollow in order to run wires through them. I don't want any wires getting pinched in this situation. So I think we'll probably end up running some wires and putting the sensor here at the end of the tail somehow. This is what we're gonna figure out today. So I'm bringing you all up to speed. I don't think we're gonna get to put this endoskeleton inside FART-A-TUCHUS, but at least the objective is to try and get this thing wired up. So let's see what we got going on here. I'm gonna just move some things out of the way so we actually have some room, right? Yeah. So LED lights, I'm gonna put you over here, and I'm gonna explain this board here briefly as I do get things out of the way, and you can see most of what we use here is our jumper cables, which is right now organized, about as organized as the $5 bin at the Walmart, you know, but we're gonna put this aside, and that's a project that I will definitely tackle later. So the first thing we're gonna do is just, let me move him aside, kind of go through this board a little bit. Now we are gonna be using the Arduino, and I'll give you a better look at that. And I'll actually zoom you guys in. Check that out, just to kind of give you a better view. And so we have our 3 light indicators. And for those of you Wrench Army members that joined us for the prototype, we actually had 4 LEDs. But what I found was that the ranges are so nuanced that it would just go way too fast, and then you couldn't see exactly where you ended up with the FART. So I trimmed it down to the green for everything safe, and then 2 other ones. So we have more comments coming in. Some people thinking that this is hilarious. Oh, and sensing micro changes in the air density, like Ash's alien detector from Carl. And then Joe is saying, any chance we can donate some money for you to build a car? He'd love to see that. I would love to build a car. It's so much fun. We need space, tools, all that kind of stuff. I've been doing most of it outside, so right now the weather is a little bit rough for that. And then Joe G is saying, this is better than my STEM course. Oh, well, you gotta, you know, I find practical applications work best, right? All right, so I'm just making sure everything is still up and running over there. So Arduino. So what we have here is our Arduino. It is being powered through this Ethernet cable, which is connected to my laptop over here. So that's how it's getting its power. It's got several pins, and we're not going to go nuts about all the pins, what they do. This is kind of like a high level basics type of overview. So you can see that I have a breadboard, and all of my components are on the breadboard. So the Arduino is powering the breadboard, and the way it's doing that is I'm running this red wire from a 5-volt pin here. It's going around and connecting, if you see this red line here, to this positive rail. So now that it's connected, anything that I plug into this entire rail will get power. And because you can notice that I am talking and getting my breath on the sensor, it's already working. It's like, uh-oh, it's detecting some kind of gas. So you'll see that go off from time to time. Here with this sensor too is a signal wire, and we have it connected to an analog. So it reads an analog reading, so it's not reading PPM. We're getting an analog reading that you can, of course, then use code to convert to PPM. But honestly, that's a lot of rigmarole. And for our purposes, we just want to know, like, is there a FART or is there not a FART? And somewhat, how bad is the FART? We don't need to get into specific PPMs. And then very tiny here, let me see if I can move this around like this. You'll see 2 other wires like right there, and you'll see one is dark and one is red, and that's our power and ground because we're connecting them to these rails. And likewise, you see this wire over here, that's ground for the breadboard there. So that's how the Arduino is powering and grounding everything. So then we have our LEDs, and now they always need resistors. I'm using a 220 ohm for this, and that's enough for this project. You can use LED calculators, you can use Ohm's law to figure exactly what resistor you need, but 220 is pretty good for most projects. And it doesn't matter whether you connect them to the anode or the cathode. So for breadboard purposes, I tend to connect them to the anode. It's a little bit less wiring, but for actual wiring, when we get to this, I will probably connect it to the ground side, the cathode side. So that's pretty much what's going on. And the sensor we're using is a 135, an MQ135. And the most popular sensors for these types of projects is either this one or the MQ4. The MQ4 is a methane sensor. Now, of course, 99% of your fart is odorless, and it includes things like oxygen, carbon dioxide, methane. But it turns out not everyone releases methane. So I thought that using a methane sensor, we might miss some suspects, and I can't have that happening. So I opted for a MQ135, which is a general like air quality sensor, and it senses things like carbon dioxide, benzene, some sulfides, all kinds of gases that could be hazardous. So people use this to detect propane or gas. So because all that is released at different levels in a fart, I thought it would be a better sensor. And now you can calibrate it to be more accurate for specific gases with resistors. You know, again, we didn't do that because if these volumes increase in a very small area, like right behind someone's butt, we can pretty much guess it's a fart and not some kind of gas leak somewhere. So that's why I kept this project super simple. So that's pretty much how this works. And let's see if we can now begin to transfer what's on here onto him. So in order to do that, I'm going to push this aside. And as you guys see, this is a live build. Sometimes things are going to work out. Other times they're really not going to work out. So a lot of it is debugging, trying to find out what's wrong before we finish our project. And of course, at the end of the month, then I take you through the entire project like I did with the corner floating shelves. So you see how it's done from beginning to end in more of a sped up process. But I like these streams because these are the ones where I learn the most, and maybe you guys learn the most. You get more of a chance to ask questions. So Joe is saying that Tesla built one of these, but the government covered it up. I am sure they did because it's a very good cause, and of course they would cover it up, right? So Michael's such a smart and funny lady. Yes, well, I'm glad you guys are liking the funny factor. I thought it'd be a fun way to introduce some electronics. Ernesto, I'm surprised by your knowledge and the engineering applied to your projects. Don't you start commending me right now. We're going to see this thing might all grenade, and he'll be like, delete the comment. But thank you. And then Joe, I can't help but laugh every time she smiles. This is going to be great. Yes, because I can't contain myself. Fart jokes are too funny for me. So the first thing that we're going to do is I'm actually unhooking everything from my board here. And we're going to prototype this out first before we actually get to the soldering to make sure that everything works. So let's start with the sensor is already hooked up. And one of the things that we need to hook up just to make sure that our code is working and everything's working, and even if the code doesn't work 100%, we'll at least get everything wired up and then test the code and get everything, fine-tuned. That's the word I was looking for. All right, so the first thing that I want to start thinking about before we get into the wiring and prototyping, that this will give you guys a chance to chime in, is where are we going to mount this thing? Remember, this thing is going to be in that, this thing here. It's going to be in our FART-A-TUCHUS animal. There's not a ton of room going on here. So we're going to have to find a way to hide it. And I have this little handy dandy case that it can go in. So it'll kind of slip in like that, and then with a cover. So these are kind of the options I'm thinking of, unless you guys have a different option. So chime in the comments, and then I'll pick whatever location you guys pick. Of course, obviously we're not going to put it up here. But I was thinking maybe here might be kind of good. And I'll give you guys a much closer look, and that's a little too close. Let's back it up. There we go. So here we have our creature. So I can mount it on its back, and maybe it'll make a hump in the animal, but I thought I could put some tufts of fur and make it look more realistic. This then will allow me to run the wire out to here, right? the wires into the little LED sockets and also to our servo. So that might not be a bad location on the back here. And Ernesto has a good idea that I should have used, or I could have used, an Arduino Nano, which is much more small and compact. Too little, too late, Ernesto. We're going giant size. But yes, using a Nano is great if you're just starting out. I do kind of recommend you starting out with the Uno because there are so many projects online with the code available that allows you to learn. Is one of the reasons I went with the Uno, but the Nano would be a much better option for it. It's way smaller. So option number 1 is the back, and I want you guys to chime in, and then I'll just kind of do a visual check of the comments, and we'll just do kind of an impromptu. The other idea I had, I'll turn him on his side, is like, what if I put it like on his neck, I guess, area? This would be kind of his neck or chest area, and that'll allow, you know, things can still be routed here. So we got back, we got neck, or we can put it on the base of the creature, you know, so I can just kind of Velcro or whatever on the base, and here are the power outputs, and I thought I can hide a battery pack inside one of its legs, so it would sit kind of on top of it like that. Now the only trouble that I see kind of immediately is that the base kind of covers some of the wire holes here that I have, and I'll give you guys a better, wrong way, a better idea of, see these kind of rails that have open would kind of cover some of that, but I can still run wires and have them all come out kind of the back end right there, and I think we should be fine. So you guys chime in. We got the back, we got the neck, and we got the base. Those are your 3 options. I think this is too flimsy to mount it over here, and I need this to kind of stay clear, his head area. So those are the options. I'll let you guys kind of like chime, turn it in your head, see which one that you like the best, and then we'll go with that. So I'm gonna put him aside for now. Actually, not too much aside because we're gonna need him. And figuring out ways to wire him, I thought we're going to use a combination of soldering and a combination of these like little DuPont connectors, because what if in the future this servo grenades itself? Well, I don't want it to be super permanent. I can always pop these screws off, remove it, put in another servo, and plug in a whole new set of wires, and it makes it like super easy. So looking at these wires here, and I'll give you a closer look-see. Some people are picking the back. Oh, we got a couple back options here. If you look closely at the wires, you know, it would help if I actually get them in the frame there for you. You have what looks like an orange-yellow one right here. I'm going to call it orange, and then a red, and then a brown. So obviously your red is power and your brown is ground, and your orange here is your signal wire, your control wire. And so the way I think I would plug it into the Arduino here, and I'm going to back this up just to kind of give us a little bit more room to play. I'm going to move him here, and him here. I'm going to go ahead and put our sensor back. That way everything is plugged in. And now, here we go. Oh dear, hold up. I ain't seeing any better with these glasses until I clean them. Oh, Joe is saying the base because somebody might be tempted to pet it and damage it. That's true. They could pull out wires and things. So that's another good idea. So all I'm doing here is trying to find the 5-volt, which is probably the most challenging thing of this entire project, is just reading the labels on the pens. If you can get beyond that, man, you are cooking. So here I have this signal wire, and I'm going to hook it up the way I had it to analog 5, the A5 pin. So this reads analog. So that should be powered up correctly. I'm going to put this little resistor here, and our ground kind of came undone. That was my doing. There we go. So now the board is powering and grounding the breadboard, and I'm hooking up all my little LEDs. And they're going into the wrong pins. There we go, 13, 12, and 11. All right, so that's hooked up. And now how are we gonna hook up this servo or micro servo? Now, of course, with micro servos or servos, mostly servos, you never wanna power them off your board. Because you're just gonna fry your board that way. But because we're prototyping, we're gonna go ahead and this time power it off the board. It's just a micro servo. We should be fine. Famous last words. I just did it. This thing's gonna blow up now just because I said that. Oh no. All right, so getting back to the project, all I'm gonna do then is using the same color scheme, and you can buy these things by the batch. Look at that, you can get male, male, female, female, and all you do is just strip off what you need. And I like to try and match up the colors that come with the original component as much as I can so it doesn't get confusing. The back is best, heat rises, and that's true. David Beck has a good point. One of the things I thought about doing on the back is making a Velcro type of enclosure that I can open up, you know, if things get too hot. So it looks like the back it is. Some people still wanting the bottom, so we'll see which one wins out. So what I'm gonna do here, and give you guys a closer look, and let's see, how can I move this? All right, it's opposite day. All right, so hopefully I am plugging these in brown with brown, and that's our ground. And then orange, or red, I mean. It looks kind of orange to me. So, and then our signal wire. Now, we could solder this. I can cut this off and just solder it, but this makes it much easier for me to replace this thing if I have to in the future. And with a little electrical tape, this will be secure enough inside the animal that it's not gonna really, I don't think it'll come undone, you know, we'll see. So now in order to connect it to the actual board here, let me move this guy out of the way so he doesn't grab all the camera focus fun. So to connect it to the board, all we have to do is take our ground here and connect it anywhere along this blue rail. So I'm just gonna pick, I don't know, right there, right? That's good enough place for me, right? And then connect the red. This is where you start seeing that having the hands of a 4-year-old is super, you know, helpful, to the red rail. And that leaves our little orange guy here. So where do we connect it? Well, we want to connect it to one of these pins on the Arduino. And I'm going to pick pin number 9, and I'm just going to turn this towards me. I'm cheating so I can see what the heck it is I'm doing. All right, so theoretically, this should be hooked up correctly. And let's take a brief look at the code that I think I came up with that I think will make all of this work. So I don't know, we'll see. Maybe it will, maybe it won't, but let's check it out. I'm just gonna slide on over here and I'm gonna meet you guys here. I'm just gonna mute the mic here for a second because it might bang around. The first thing we did in our code is include our servo library, and that allows Arduino to basically know the functions of the servo. I'm not going to get super deep into this code because you know, we can save that for an actual course or a lesson. I'm just kind of giving you guys like a high level overview, just some generalities to go through. And then the next thing we tell the Arduino is, where's all our stuff plugged into? Like, we know where it's plugged into, but the Arduino doesn't. So our green LED here is plugged into pin number 11. Our yellow LED pin number 12, and our red LED pin 13. And then the sensor is plugged into A5, which was that analog sensor. And then we declare our object, which is the servo. And here I called it my servo. We have one servo. You can call it anything you want. I could have called it nose servo. I could have called it cupcake servo, you know, and that would have been fun. But you always have to remember that you are going to come back to this. And at some point, what does cupcake servo mean? I mean, you may not know. I'm just going to check and make sure that you guys can hear me. Yes, and it looks like you can. We've declared our servo, and we want this servo to start at position 90. Now, most servos go from 0 to 180, and it can do that big sweep. But because our nose is, going this way, well, we want the servo to start 90 so it doesn't start like crooked and stuff. So I picked 90. And then here, we're setting up how we want our pins to work. Now, on the Arduino board, by default, they're always inputs. So you only have to really declare anytime you want to name something an output. But I declare everything because it makes it easier to explain and for me to review it later if something goes wrong. So for the green LED, all the LEDs here you see, I've named them as outputs, meaning we want the voltage to go out to them. The sensor is an input because we're going to be receiving that analog information through to the Arduino, so then we can see what that reading is, and then that reading will drive the LEDs and it'll drive the servo. So the sensor is an input. Here we're saying that we attached our servo to pin 9. Serial begin, we're going to skip that for now. We're going to revisit it later. Here we're just setting up the sensor to read. And then this line we're going to skip. It's related to the other line that we just skipped, and we'll get to that a little bit later. When we see it in action, it's a little bit easier to explain. So the way we want to start this project before it senses, when we first turn it on, everything will not be getting power. Like the green, yellow, and red LEDs we have set to low, meaning they're not getting voltage until a couple conditions are met, which is later on down in the code. And then keep firing your questions. And yes, everybody's saying that the sound is like A-okay, so awesome. Okay, so where are we in the code? Okay, so these are the conditions that actually turn on the LED. So condition number 1, if the sensor reading is less or equal to 400, and again, this is an analog reading, not a PPM reading, then the green LED, we want it to be high. That means it gets the voltage. High, low, no voltage, high, yes, voltage. And it's going to illuminate green. So almost immediately when you turn this on, it should just illuminate green unless like somebody just let it rip like right that second that you're turning it on. Also, these sensors need time to warm up. So you definitely want to get your unit turned on before you're ready to use them because it needs a couple minutes. But we'll see that a little bit later. So anything 400 or below, we're going to say that that's green. Everything is super safe. Then the yellow LED, to turn that on, if the sensor reading is above 400 but below 500, that's when the yellow one turns on. But in addition to the yellow one turning on, this is where we start loading our servo action. And if you look, remember we set it to 90 degrees and that's how it starts. And it's now going to sweep to 160. So why not 180? Well, if you remember, the servo is put in between those two eye sockets, and my fear is that if I turn it to 180, it's going to hit it. Conversely, if I turn it to 0, it's going to hit it. So one of the fine-tuning things we're going to have to do is figure out kind of what that range should be to make it realistic and not just start to really deform our buffalo bison face. So it'll turn to 160, then from 160 it'll turn back to 20. So basically this is a sweeping motion that the nose is going to do. And for each motion I'm giving it 15 milliseconds to perform that motion. So yellow light is on, we're getting kind of a sweep of the nose. Something is stinky. So if none of these conditions are met, meaning it's not below 400, it's not 400 to 499, well then the only other option is that this thing is like above 500, right? So that means that the red LED will then be turned on. So things are like dire. And again, you'll see the same code for the servo except one difference. And that is this 7 seconds here. 7 versus 15. So that means that the nose is going to move a little faster. So I thought that would be kind of a cool differentiation other than just LEDs for us to know something is going on. So this is kind of like the code that preliminarily I put together, and I tend to attach things to the same positions. It makes it easy for me to then just copy paste the code for other projects where I'm attaching LEDs and stuff. So this has been a brief overview of what the code looks like. You know, even if you don't code or any of that, it gives you an idea of at least the organization of what it does. And then when it gets to the bottom, it literally just starts over again. And that's what Arduino does. It just repeats in a loop whatever you tell it to do, like a robot. All right, so I'm gonna head on over to the other camera, but this time I am not gonna turn off the mic so I don't forget to turn it back on. So that means there might be some bumps and dings. So volume down, people, volume down. And I'm gonna go ahead and move us to the other camera. All right. So now slide on over. All right, so the booming and stuff should be gone, and let us continue on with this. So we got this hooked up, we have our servo hooked up, and you'll notice that I have a laptop here, and I am just gonna like fire it up real quick, and I should have the same version of the code on this computer. We'll see. Let me just get in here. Volume down means cursing is coming, says Joe. I will keep that in mind in case this doesn't work, and then I'll just like hit the volume off and be like, and then you guys will know something is up. All right, so I'm just going to turn that off and make sure I have the correct code. Oh, nope, that's the wrong code. That would have caused some problems. So let me just open the correct one and open. All right, I'm just giving it a once over very quickly here and make sure I didn't accidentally hit any keys that might have added, you know, an extra semicolon or something. Sometimes it's the dumbest things that will, you know, mess it up. So what we're gonna do now is see if this even works and if the servo or Arduino grenades, because I plugged in the servo to the Arduino, which I specifically told you guys not to do. So everything is hooked in there, and I'm going to hook the Arduino. Let me give you guys a better view and see if I can, whoop, wrong way, do that and make myself perhaps disappear, just to, you know, give you guys a better view. So I'm going to hook this into our Arduino right here in the barrel. And now it might have other code loaded in from a previous project, so it might go a little haywire. I'm gonna download the code that I have in the computer here and upload it there. So you saw the red light. Oh, look guys, look, it's moving and the yellow is on. Now again, anytime you turn on the sensor, it does need a little time, and I'm talking on it, giving it that like carbon dioxide. I'm getting closer and trying to breathe. Look guys, it's moving faster. Now, one of the things I'm already seeing is I think our 20 to 160 is a little too broad. Don't you guys think? I think that it'll, I think it's gonna hit the sides. So I think I'm going to, you know, shrink down that range, maybe like a 150 or a 140 to about 40, maybe 140 to 40 might be the way to go. And to kind of give us a better idea here, I'm just gonna mimic the nose, because again, we're moving fabric, and moving a nose, the pivot here is very small, but if you follow it out, the bigger the range becomes. And this might be like way too big for a nose, and we might find that something like this might be way better. So I'm just going to give it one more test. I'm going to get like really close, and whoop, there we go. So you see me, it's yellow now because I'm talking real closely to this, but I'm going to get super close and breathe on it. I don't have enough carbon dioxide. Hold on, I'm gonna take a really big breath. All right, guys, I'm gonna need something more potent than my own breath, but you can set it off using lighters. You can set it off, even putting some alcohol by it should set it off. But we all see that it does work. We have our servo moving, and it moves slower with the yellow and faster with the red. So, and David Beck is saying, yep, too wide, and I agree. So, we know we're gonna change that in the code, but I say, listen, the code works, and those are simple values we can change. And I'm not going to put the actual popsicle stick on it just yet because I want to strengthen it just a little bit before putting it on here. So I'm going to disconnect this. There we go. And I'm going to move this away. So those bits of code that you saw that said like serial something and serial something, all that does is allow you to open a monitor window that you can monitor different values that you tell it to monitor. So one of the things that I like to monitor when I was setting this up is what analog values I was getting from this sensor. And that kind of helped me before even setting up LEDs kind of find out what is a realistic range for a human. There's no sense in setting the red so high that no one can even achieve it because, you know, you need some alien fart to achieve it. So I wanted to keep the LEDs kind of realistic. So the serial monitor windows helps you, you know, kind of find out. It also helps you to find out when something is not working. Like I kept getting a 0 and I'm like, wow, I have no poison gas around me. But it turns out I plugged it in incorrectly and it wasn't getting power. Well, of course you're gonna get 0. So, twitching nose, not Santa down the chimney movement, says David Beck. Bet the dog would get it moving again from Don Stricker. Yes, he would. Trust me, he would. Yeah. And I always get blamed, especially outside on our walks. But I'm going to move this little guy aside because one of the things that we're going to do is totally eliminate this breadboard. We are only going to use the Arduino and the wiring. So we're going to do some permanent and semi-permanent wiring to the Arduino. Now for real production projects, you typically cut the Arduino out and you make your own Arduino. All you need is your microcontroller chip. It's not too hard to do. I figured for this project, we would save that for a whole other lesson. And the reason I like making not super permanent things on the Arduino is because I can just like pop the wires out, use it for another project, and then just shift it back and forth between projects. I have a couple boards. But it's always nice to have that option. So one of the things that we should do is, did you all decide where we're even mounting this Arduino? Because this is going to help us try and figure out how long our wires have to be. All that breathing in and out has made me winded. Trying to get all that carbon dioxide to activate the sensor there. So without the case, just to kind of see, I think a lot of you guys were wanting the back location just because of the heat dissipation. And what I can do also in the cloth is put in a mesh area in the cloth that allows the heat to escape through the mesh. The other option was the neck option and then the bottom option, which is probably the toughest option to wire because the base kind of covers some of the holes we need and I'd have to get a little bit creative. So I myself might be vetoing your guys' base option right there just for that reason. So in any case, we can get started. Probably the most difficult is the tail situation here. So I'm gonna move this aside and we have to figure out a way to attach this sensor, which I'm popping out of here carefully. These sensors are cool. They're very inexpensive. So they're fun for just little projects like this. And somehow we have to attach it to the tail. And I'm gonna give you guys a much better view of what's going on and maybe, you know, zoom you guys in just a little bit there. So, so where is it going? Don Stricker said. I think the back seems to have one out. And well, Keith does have a point. He's saying the bottom seems to be the theme of this video. but back would be better. Yeah, so, you know, in keeping with the theme, the bum would be better, but I think the back for heat dissipation. Also, this neck area is extremely difficult to access once this thing is inside. And there's no natural seam in the animal to be able to access it. See, as you notice, I went ahead and tore through, or just, you know, took out the stitching along the natural stitch lines of the stuffed animal to make everything go back together, more hidden, more like not looking like some kind of butcher job. Although I can't promise at this point what this thing is gonna look like. So we're gonna put him aside, but that's the idea. So the back, I think, would be the perfect place to do it. So one of the things we have to try and figure out is how to mount this thing. I mean, like this, you know, that's kind of weird. And remember, this is kind of fragile. It doesn't hold a ton of weight. One of the ideas I had was to somehow get like some block, but this is moving, so that's kind of difficult. Maybe I can put a hole and put a piece of string here to kind of hold it, but that's just kind of awkward. So one of the ideas I had is just to put it right here, and we can just hot glue gun it on. One of the things we need is access to these pins. So it really needs to be in a way that I can hook things up. So we can either hot glue gun this way, and I love hot glue guns because it's always undoable. If you decide you want to do something else, you can always undo it. But another idea I had, is maybe use like a little thing like this, and see where I'm going with this. I'm going to give you a much more close-up view. But what if I were to hot glue gun this somewhere, like maybe here, like that, right? And then that would go through this hole, right? And it's hot glue gun together. And we'll just do this, right? That kind of seems to work. I don't know. You could just zip tie it back there, says Harry. You know what? He may have a point. Well, where would I zip tie it in a way that doesn't crush it? We do have some room here that I can potentially run a zip tie, but this does move. It does get smaller and it does get bigger, so it does need room to articulate. So zip tying might constrain it a bit here. So I'm gonna keep the zip tie idea in mind. I'm gonna try this one first and see how horrific it goes. And then trust me, Harry, I will be crawling back to your zip tie idea so fast when this idea blows up. So I'm going to heat up my my hot glue gun here. And for this kind of build, you are welcome to hang around, watch the whole thing, heck, come back. There's a lot of like, oh, wait, hurry up and wait in these types of things. So let's see if my cord reaches. Now this thing is like ancient. I think it's quite a few decades old. As you can see, the nice 1950s like gold going on. So get this plugged in. I figure that's probably one of the hardest things to figure out in this entire project, is just figuring out how this sensor goes on here, and then we're going to try and wire it through the body, and then wiring up the LEDs will be soldering versus these little hookups. For the sensor, I'm actually going to use hookups similar to these because it makes it easy to pop it on, pop it off in case the sensor just fries or goes bad for whatever reason. So let's see if I can dap-dap-roo. And the idea is to kind of just, it's trying to escape. Put it up there, just like that. What's this thing? Sometimes I'll just do this. Let's see how hot it's getting. Warming up. My ancient glue sitting in here. I don't know how old that is, but we'll see. So as this heats up, I'm gonna come up with a plan for wiring. I'm gonna back this up a little bit. This servo situation. Now, since we're only going to the back here, this thing is just entirely too long. So I could splice these wires and shorten it, but it might just be easier to wrap it around the neck here and then plug it in, which is what I think I'm gonna do rather than going too nuts. How are we doing? Almost. It's getting a little soft. We're almost ready. Coiled wire, maybe. Yep. Rachel, you're the best. Goofy charm. Yes. You either love the corniness or you don't. There's no halfway point there. Ernesto, won't the screw cause a short circuit? The area where we're going to be putting it is actually these tiny little LEDs, indicator lights, basically. And so we're going to be putting a cushion of glue and then putting our screw. So we should be okay. Famous last word. We should be okay. Now this can get a little bit hot, you know, especially these pins right here. But I've never had it so hot that, you know, it catches something on fire or anything like that. So I think we should be good. But, you know, obviously if we see FART-A-TUCHUS' tail caught on fire, we can assume two things. One, I botched this wiring, or two, somebody really just grenaded the sensor with what they're putting out. So either way, it's gonna be bad and it's time to drop and run. All right, so this is always like the part where it's like, waiting for equipment to like, oh, we got a little bit of glue. We got a little bit of glue. And I'm going to do this. And Joe is saying you should consider making FART-A-TUCHUS a sign to tell people what he does, then make a remote for FART-A-TUCHUS so that random time you have a guest, you can have a blast. Yeah, we should. I thought of making it a meter that goes like this, you know, in degrees of worseness and making it public. But the idea of this is to be hidden about it. We want to be hidden. All right, so let's see. Another idea is to just mount it like that. What do you guys think? Hold on. It's easier if you guys can actually see, right? So you can mount it with my idea or like this. I'm just concerned with putting a tiny bit of glue. I don't know if that'll hold well enough. Glue the wire. So Ernesto's saying an idea to wire the sensor would be to glue the wire along the braces, thus covering the shape and the movement. Yes. One of the things we're going to do is try and use these holes right here to weave the wire through it so you don't even see it. It should be seamless with these things, which is one of the reasons I went with holes versus rivets. So this is, you know, just from a leather making kit, and you can do it that way. So I am, like, guys, I'm telling you, I am half tempted to just, boop, glue it that way and see how it holds. And if it doesn't hold, then turning it around and using my screw idea, you know, because this does get a little hot. Maybe something like this might be a little bit better. And this can read from all sides. So it's not like the fart has to be hitting it, you know, head on. So that might work. I think I'm going to try that first and see what happens. So I'm going to turn him sideways, take a nap. He's under anesthesia right now as we do our surgery. And I'm just going to put a dabaroo, and I'm trying not to get it where the moving parts are. So now I'm going to go like this right next to the heat. Whoop! Where I can burn myself. Why not? Let's see. Let's see how well this holds. If this is just like a fail, then we'll try the other idea. And I am liking Ernesto's idea of gluing. You know what? That's holding on pretty well. I'm liking that. I'm just gonna let that settle. And here we can see the markings, so that's pretty good. I can, remember how everything hooks up. And so I can start preparing the colors we're gonna need. So I believe since the servo is orange for signal, I might as well stick with the same theme. And here, I guess they have a black. They have like a brown for ground, but I really love my blacks for power source ground. So I think I'm gonna stick with the brown. You know what? Check how these are already arranged. Brown, red, orange, just like the servo. And I can pull them all out just like that. And be ready. So one of the ideas I have is to use these types of wires to go through the entire tail, or we can splice. So that I haven't decided yet. For the eyes, we're definitely going to solder. For the servo, it's going to be solderless. And then for this chip here, or the sensor, it can either be solderless or soldered. I don't want to solder to these pins in case I ever have to swap this out. I can use a little bit of a heat gun and get the glue soft enough to pull this off and then pop on another sensor, and I already have connections ready to go. So I don't try and solder where there's going to be fabric and all kinds of stuff and have to completely take it apart. And the gloves. We are going gloveless this time. And so I'm going to get all glue all up on myself. So guys, this seems like it totally worked. One for us. That means that a whole bunch of other things, may not work. When you get that first one from the get-go, like that first win, beware. So that seems pretty good, so you extend to the person and extend back so you don't have to, smell anything yourself. And it looks like we're still getting that good range of motion. So I didn't accidentally glue anything that shouldn't have been glued. So you see kind of the scissor action happening there pretty well. And this seems to be on there pretty sturdy. So I'm going to move on and be cautiously optimistic about our thing here, our connection. So I'm going to move this little Arduino board aside so I don't burn it all to heck. And I'm going to move this glue gun. I think for now that's all the glue gunning that's going to happen. So I'm going to go ahead and get this settled. Move that. And put them here. And the next thing we're going to fire up is the soldering iron right here. So because my plug is on that side, I'm going to plug it in on this side. And I'm also going to move this out of the way. As much as I love having a ton of stuff all up in the way so I can get glue and I can get solder and burn the heck out of it, that's like apparently my favorite thing to do. Leaving all this stuff here. So I'm just going to hide this down here. There we go. Hopefully I don't kick it. All right. So I'm going to swap you positions and put you over here. So what do you guys think for the sensor? Should we just run the style where they easily hook up all the way down, or should we start them with this so that way I can swap out the sensor, cut off these little ends, and then continue running them, down the thing there, down the tail. And I imagine we probably would have to do this with the tail extended because that gives us the true length that we're going to need. I'm going to move this over here. And I heard it helps that if we plug it in, it totally helps. All right, I'm going to move this laptop back a little bit more and move this here. I find that Gorilla Glue works best. I put that, he puts it on everything. Yeah, it's like hot sauce. You put it on everything. So if you guys are just joining, I see some of you latecomers. We are in the middle of our FART-A-TUCHUS project. Let me just plug this in so it gets warming. So down periscope. Up periscope. All right, so we made sure the code is working. We've done our prototype. Now, next thing, we're actually doing the wiring and trying to eliminate this breadboard right here. So that's the objective. So we don't have a whole bunch of things that we have to fit on his back. If the connection fit, put the cable as it is. Okay, so that's Ernesto's idea. And wow, I think we have like 100 chat messages now. That's pretty cool. You guys are like helping me along here. So since we have that suggestion, I'm gonna go with it. Do it as is. So it's like that 10mm socket, right? It just like disappears on you. And the worst is like when it's on your head the entire time and you're sitting there for 20 minutes trying to find it. I'm gonna see what the heck temperature I have this on. There we go. I look all studious now. All right, so the objective here, and I'm gonna swap us and get this into a place where you guys can see here. And do this so you can actually see. Whoop. All right, so you see my little pins, and if you look really closely at the white lettering, they're labeled. So VCC for power, GND, ground for ground, and then we're gonna look for the AO, which is the analog out. Now there's also a DO, a digital out, and you can use that if you have a threshold. Say you wanna set it to 400, anything over the 400 then will make stuff happen. We want to measure gradations of things, so we're gonna use the analog. That way we get the yellow option and the red option. And all I'm gonna do is just take this, and I got a little string of glue right there. I just broke it off. That way this can get as hot as it wants, and I might cover it because we are gonna have some fabric there. So I'm gonna put a little bit of like a heat shield, if you will, on there. So on to the wiring, and I'm going to kind of get up here so I can hover over this thing and see. So the very first one says AO, which is going to be our analog. So I'm going to put the orange one on there. And then the next one is ground. So it's a little bit in reverse than what this is. I'm going to skip one, which is the DO. And then the second to the last one here is the ground. Maybe I should have wired this before gluing it on. Makes it a little bit tougher. And the VCC, which is our power, goes right here. All right, so this is pretty good. And then after we wire, what I might do is run a bit of an electrical tape just to tie things together, not really for insulation necessarily, like a heat shrink tube, but just to kind of keep things from, although it doesn't pull out very easily, so that's a good sign. All right, so now we have this, and I'm gonna pull out just a little bit, zoom out if you will. Now we have this end, and we're gonna try and wire it through. I'm gonna stretch this all the way out, and I'm gonna rest him here. Hopefully during all this wiring I don't actually damage all this and then have to start all over again. That's the worst. All right, now all three of these, you know, clearly aren't gonna fit there, so I'm gonna have to weave one after the other. And also with these connectors, they do make them in different sizes. I have them all the same size, so I probably should have thought about getting them in different sizes for this, so that way I don't have to run a whole bunch of them. So that's that. And what I might do is get stuff mostly done, so that way we can do a little bit of everything and at least get started with everything. We may not finish it. So I'm gonna run through this middle one here. Let's see if I can do it. And then just kind of go top to middle, top to middle, top to middle. That way I don't eat up so much wire. And this one. So we're just kind of basically sewing this back and forth, and we're a little bit, I wonder if I can do it. Probably not. Nope, I can't. So we might have a little bit of a hump, but I can also give it a little slack and put the hump here. So let's see. This will get us almost there. And then I can do a male to female. So let me back this out so you guys can kind of see what my pre-planning is looking like. You know, so here we have a the pins are female, so obviously we have a male to male going on here, and then I have an option of doing female here, an option of going male to male here, and then female to male into the Arduino, which is going to be in its back. And I think that's what I'm going to try and do. So let's see if I have another sequence of 3 that I can use that's of the same color. And Main Gun 07 is saying he lost his glasses once, bent over to look under the bed, glasses fell off my face, put them back on so I could see under the bed in case they I'm an idiot. Oh, listen, you and me both. It's the worst. Because then you always feel so dumb, you know, afterwards. But it's like, no, you're not dumb. You have so much on your mind that you just kind of, sometimes I find retracing my steps is the best way to go. Let's see. All right, so Ernesto is saying, consider the length is increased by contracting the joint. That is true. So I'm wiring it this way with everything extended fully because I know that that's the maximum length of wire. So when we extend it, we don't run out of wire. But when this contracts, Ernesto does have a point. The wire is going to shrink or, you know, have more wire left over between the joints. And so we do have to account for that. So I'm going to loosely kind of do this, and then it'll give us room to kind of adjust the wiring as needed. So I'm going to go ahead and match up my colors here, and I'm going to go back into Zumo Vision for you guys, and I'm going to match up the orange. And I'm going to match up, and again, I'm going to electrical tape. I'm using it as a verb, all of this, so that way it just, you know, secures the connection because we are not soldering. And who knows, oh, you know what? I should probably go like this and get it in an order that I can just put it in. There we go. As a trio instead of trying to fight it. So just checking I have everything correct there with the colors, and we are going to go ahead and, where am I in all this? So it's going to go in here, and we're going to go one at a time because of these little connectors. Got the orange, got the red, and got the brown or black. It's brown, but that's our ground there. And one already came undone, hence why we probably need a little bit of electrical tape or a slight goodad of our glue gun situation. Now his tail is going to be kind of puffy, so it will hide some of these imperfections. So Dawn is asking, if one wire comes loose, will it be like a string of Christmas lights and none of it works? Yes, if the power wire comes loose, then, well, we have no power. If the signal wire comes loose, we'll have power, but the nose is not going to move because it's not getting that signal from the Arduino to tell it to move. So we are kind of in a Christmas light type of situation here. So I don't know. Soldering might be a better option, but I'm going to try my electrical tape one first and see what happens. And it's fighting me. There we go. Do have kind of a Frankenstein there, but I'll figure it out. If this ends up being too bad, I might just cut and solder them together, and we can always do it that way as well. But this will give us an idea of kind of figuring out how we want to do this. Because sometimes the first time you do it just ends up not making the final project. Because sometimes you just learn better ways, and that's one of the things with the plans that I put out. Oftentimes you'll see that they've changed from how we've done the project because I just figure out a better way to do it, and I share that with you all. And the way you learn is just doing these things like this and having you guys around to help out in case things go haywire, or if it works, we're here to document it together. And I'm trying to stick this upside down without looking at it. And that's, you know, part of the problem right there. Why aren't you not coming? The ground wire is refusing to play. So far, let's see what kind of movement we have. Yes. So, like many of you said, you get a little more slack once it's closed, and when it opens, that wire pulls a little more taut. So electrical tape there is definitely going to help us out in not getting it messed up. And one of the things I thought about doing is, since we are running Velcro on his top, I might as well run a strip of Velcro when we attach the tail. Keep a strip of Velcro, keep it just Velcroed. Anything comes undone, we can always, you know, take a peek in there, get it all hooked up again. But I think a little bit of electrical tape there should help us. So Don is keeping his fingers crossed. Listen, I am too for this, because by the time you string it all, it might just be a hot disaster. This I might actually have room to get all of these guys in here. There we go. And main guy saying, yes, less bending and more slack for adjustment. So he is right there. He is correct about that. So let me see what I got without knocking the soldering iron. So this is what we have so far. You know what it reminds me of? The lamps you see on Amazon, the old-timey kind of scissor lamps. But one thing I already see is that I highly recommend you guys not use popsicle sticks if you repeat this, because they are, you know, it is kind of flimsy. But for our purposes, we'll kind of see how it works, have some fun with it, and that's how we roll. So I'm going to finish this up. How long each one does once you hook it up? About 1, 2, 3, 4 joints. So if I hook it up here, I'll get 1, 2, 3, 4 joints, and I'm still gonna need. So I'm going to hold off on this and go with, here's our females and here's our males. I'm going to go with this one. And then go with, just making sure you got plan this out. All right, that guy can stay there. So if I have little male ends on here, I can do that option. And then this option, I think I'm gonna need one more run though, is the thing. So then I'll do this and then this. All right. The worst is like if you mess up and then you gotta de-thread it all. It's like, no, don't de-thread it. But you guys get the idea. We're just gonna continue weaving this all the way till we get to the back area, so we can then put the pins back into the Arduino just like we did before. We're gonna hook up the orange into the analog, and then the power to power ground into ground, and we're gonna be tying the powers and the grounds together. Actually, no, we're not, because we have LEDs and they'll be going into totally separate pins. So ixnay on that idea. So that kind of gives us an idea of how that's going to work. And I think the soldering iron might be ready to go, so we can do a little bit more, some fun stuff there, right? So now, of course, for our breadboard, we only have one of each color. So we got a Cyclops FART-A-TUCHUS going on right now, and that's just not going to do. We're going to do 2 of each color. This was for the purposes of seeing, does the code even work? Like, can I even get this thing working before, you know, using way too many LEDs? So with these LEDs here, the way we're going to wire them, and I'll give you guys a much closer up view, is you're going to notice, well, how do you tell anode from a cathode? And remember, the anode has to get the power wire. So I'm going to use like a little resistor to help point this out, and I'll move this into the area where you guys can see. So here, this longer lead right here, that's always going to be your anode. So that's how you know the power has to be hooked up to this guy right here. Then you're going to see a shorter lead, and that's your cathode. And so, of course, that goes to ground. And your resistor can go on either. It really doesn't matter where your resistor goes. For prototyping, I tend to put it on the anode because it's less wires on the breadboard. For actual wiring, I tend to put it on the cathode. And you can do either. For me, it's just important to keep it consistent, you know, so that way sometimes I'll feel along a heat shrink. If I feel like a little hump, then I know that that's negative, you know, especially if you start using different colors or you run out of colors and you substitute. Months later, you can't always remember how that works. So I'm going to move FART-A-TUCHUS aside here for a second and just kind of set up my workspace and kind of get everything out of the way and use these little helping hands. So let me see if I can maybe take this guy off, this magnifying glass. The magnifying glass is awesome, by the way, but it might be in the way. Or maybe if I can lean him back, he doesn't come off very easily. Yeah. So then we'll just lean back, and out of the way. But he does have like a little light function, which is pretty cool. All right, I'm gonna move him into position, and I'm gonna move these helping hands probably over here away from the soldering iron, which is like hot. I can already feel its heat. And I'm going to prepare what I'm gonna need, and we're gonna start with the red LED, probably the most important LED of the project, because that means military grade run, and hopefully this person carries a permit for what they're releasing. So I'm just gonna, oh, that's kind of, I forgot this comes in like a little pen here, and I have my wet sponge, but I really actually prefer to use this brass cleaner. I think it gets the tips a lot cleaner. I also have rosin, which is kind of for this project maybe a little bit of overkill, but that helps keep your joints really clean. But this has a rosin core. So a lot of the smoke you see rise up, a lot of people think that oh no, it's lead, you know, because there's lead and leadless, you know, without lead. I personally like the leaded. It's much easier to work with. It leaves those kind of shiny, chromy connections. So a lot of people, when they see the smoke rising up for when you're soldering, they think it's like lead, but it's not. It's actually your rosin core that's burning off. You would have to run a much hotter iron to get that lead. So I'm going to actually vamoose around the table. I have a small fan set up here outside of the view, and I'm going to go ahead and turn that on just to kind of help get those gases away, or not gases, but the smoke fumes and things like that. All right, who is going to provide the first test sample? Carl is asking. And that's kind of a funny thing because, let me see if I can get this. Here we go. The first fan I had was a shop fan, and it just blew so badly that it would cool the iron, and I couldn't get anything done. So let's see how much I can, how well I can set this up. Let me get this guy into view here. And maybe I have to, whoop, wrong way. There we go. Let's see. The trick is making it easy for you guys, but for me too. You know, oftentimes you guys get a great view and I'm just sitting there like, you know, up and over trying to do this. And so I'm going to get this little guy hooked up here. So you can see the longer lead is the one that's closer to me. So that's closer to me. And then the short lead is closer to you guys. So let's start with bringing this little hand closer. And it's a good idea to trim the leads. I don't think I'm going to. I think I'm just gonna let it flow nice and long. And we want to get these guys, you know, kind of like first date. Hey, how are you? You know, they're asking their questions, shaking hands. Now I'm gonna get my glasses on and see if I got the cathode touching this little lead here. And it just does not want to socialize. And sometimes it's easier to put a little bit of, you know, basically tin. That way you get a little glue stick. But I had them, oh, there we go. They're kind of touching. So, oh, they untouched, but we'll get them to touch. All right, so the first thing I'm gonna do is clean my tip by just kind of sticking it in here. See how nice and shiny it already is? Just by doing that. And then where's my rosin? Not my rosin, my solder. I am just going to tin the tip. Tap it against here. This is a fine leopard print coaster that I have that's made of stone. And wow, that's like really nice and shiny. So you just want to keep, you know what, I'm actually going to take this out instead of, I thought the pen was a cool idea, and I actually changed my mind about that. We're allowed to do that from time to time. Let's change our mind. All right. So Carl was asking about test subjects. And that's the funniest thing, because when people heard about this project, everybody wanted to volunteer, like everybody. Oh, I'm gonna go eat beans, and I'm gonna, you know, do all of a sudden, it was like, when I called upon the test subjects, they were a little bit shy, I do admit. So I'm gonna start by, I'm gonna just kind of clean, clean, clean. The more it sits in the air, you get oxidization building up on the tip. It does get a little bit gross. So let's tin the tip. And I'm going to try and reach under here. Please don't break apart. And I'm heating the connection here first before applying the solder. And I'm heating it from the bottom. That way when I apply the solder on top, it'll like wick through. See, it's still a little not hot enough. So now it's hot. And then see? So we're gonna let that cool off, and more power, my dear, Dawn is saying. Could you have used RGB LEDs? Yes, Ernesto is asking. You absolutely could have. The hookup is a little bit different for that. So that would actually be cool if his eyes would do like an LED type of thing, or RGB type of thing, like you see in those light strips at the clubs and things. So that gives me an idea for version 2.0. The hookups are a little bit different. This is a much easier hookup. So I figured it's a great place to start. This wire is a little bit short, so if you see me battling it out, that's why. So let's see how this, okay, so I'm wiggling it. We got a good connection there. And next we are going to hook up our positive to the other end, and then we'll hook up the negative. And we'll use our heat shrink tubing. I always forget to put that on, and then I gotta cut the wire, or sometimes, you know, I admit I just do electrical tape, you know, sometimes. So that's our secret. Yeah, I'm gonna have to delete this video now thanks to that secret. All right, so that's done, and now I'm going to use, let's see, I think for this is actually not going that far. I'm just doing this to show you guys kind of what I mean. I'm trying to figure out whether to use real wire or just strip the noggin off one of these guys, because remember, we are going to have to use a pin to go into the Arduino. So whatever I do, I am going to have to cut a noggin off of one of these with a pin on it and the male end, so we can, you know, be able to hook it up. So one of the things I can do, if we don't have that long to go, is already take one of these and cut off the section I don't need, solder those together, and then I got a little pin end. So let me kind of judge the tract of what we got going on here. So if I did do that, maybe I'll take a male to female, then it would be coming out the eyeball, and the Arduino is gonna be like right here. So I think we're gonna be okay just using one of these guys instead of tapping into the real wire. The soldering is the same, you know, however you decide to do it, the technique is the same. So let's get back into it, and I'm going to use a red one to indicate power, and I'm going to just, let's see if there's a lonely little red one right on this side here. So that's a brown. I'm going to use this here, this brown one I'm going to save for the upcoming wire, but for this wire I'm going to do that. And we're going to go ahead and cut this little end, the female end, off. So let's do that. And I have, my wire cutters are somewhere. Move that out of the way so I don't knock it off. Oh. My garden shears are in the way. I like these yellow ones. There we go. I like these little yellow guys. But for the really tiny wires, I may actually have to switch to this like little cheapy thing that came with that kit. But it works so well on like 24 gauge and above wires versus something like this that you struggle with. But first things first, let me make sure I cut off the right end, right? So I'm going to cut this male end off, or yes, male end off. All right, now let's strip this thing. Let's strip it. And let's see if I can get it to work with this one first. And I'll try this littlest hole. And I'm going to give myself a decent amount just so I can make mistakes, right? Go like that and strip. Now, I am going to do another one just to test, because I think I might have been a little bit too rambunctious and cut off too many of the strands. And of course, if you cut off too many strands, that affects your signal flow there. So we don't want to do that. I'm going to give myself a bit of room and maybe take it easier this time. Let's just, oh, so lightly. That's better. As you can see here, I think I probably cut, you know, a few too many off, and you can just look down it and you can see these short little wiry ones you cut off. So I'm going to toss that one. Now this one, I'm going to go ahead, and it's stranded, so I'm going to just curl it like that. Don Stricker is saying, Don Stricker is saying he watches Home Improvement. I used to love that show. I know they have reruns on it from time to time. All right, let me bring this back into play here. Let me move this wire out of the way. It loves being in the way. And one of the things I'm going to do is probably release our little thing here. And maybe not him, maybe not you. And I'm going to wind this wire around the anode. And I'm going to try and do it in a way. Whoop, there I am winding it around both. That'll work out really well. Can you imagine? Come here. The trick is to keep it wound. And I know my hands are totally in the way. I'm hoping that once I get this done, I will release my hands and you will see my handiwork here, for better or for worse. So you're going to have to pardon the hands for a little bit, but you could probably see what I'm doing. I'm winding this situation around, and I like to try and coil it as much as possible. Now, I cut way too much off, but it's better to cut too much than not enough. And let me coil it. Oh my gosh, I need like the hand of a 4-year-old. It's like children for hire for electronics projects, right? They should have a website where you just tell them the time and place, or if you're working on your car, stick your hand in that hole and fish that wire. That's what we always used to do for our parents. You're nothing more than tiny hands. All right, so, and David Beck is saying tube shrinking? Yes, we're gonna get to the tube shrinking. Oh, he cut me. I should have put the tube on first, but I'm wondering if I can put it on this end. Ooh, I'm gonna try and cheat, people. I'm gonna try and cheat. Let's see. Do cheaters win? You know what they say, cheaters never win. Let's see if I might win this time. So I had this cool little pack that came with this kit because I only have black and red back there at much lower gauges, meaning thicker wires, too thick for a project like this. So let me see if I can be rewarded for my forget. And didn't I tell you guys that from the beginning of the stream? Like, oh, I always forget to do this. As evidenced, right? So, let's see if... Yes, people, look. It's like it never happened. Yeah, I'll just edit that whole part out. No, I'm kidding. I usually leave all my mistakes in for you guys to see what happens. All right, so the heat shrink tubing is on. I'm gonna try and solder this thing now. All right, so the attempt. And you can see how dirty our tip just got. It's just sitting there and it got all dirty. So we're gonna go ahead and clean that grossness off. Like that. This fan's making me cold. All right, and we're gonna... And I'm just gonna... Iron was right there, but you know what? I'm gonna go for it. Ooh, it's hot, 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 hot. I'm going for it. I'm going for it. All right. So I'll give it one more clean. And I'm just gonna get this ready by pulling it. I might have been overzealous with my... There we go. Pull it a little out. So I'm gonna get this out of the way so you guys can kind of see what's going on here. But I've wound this wire here onto our anode. And just gonna load this up a little bit, get it going, and pop it right under there. Heat up the connection. Then, let's see. Oh. This coil here. All right. Put that. Clean, 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 clean. Put it back in its little thing. And this wire could not be any more in the way right here, but that's what I get for short-wired things. All right, so I'm gonna let this cool just a little bit. It's just slightly out of view for you guys. I'm gonna roll it back in view. So we have the resistor on the cathode end there, and then we have our positive wire on the other end, and we are going to heat shrink this in a little bit here. So before we do, because I'm gonna have to switch, the amp situation in this garage is quite poor. So I find that, you know, I'm always fearful of plugging too many things in, especially when we're live streaming, because it has happened where it just, everything goes down. And then people are like, where'd you go? Where'd you go? Oh, and David Beck said, winning. Yes, he is rewarding my forgetfulness, my procrastination, and my totally warning you guys. See, I'm like a seer. I can see what happens in the future. Like, I'm going to forget this. And it happens every time. You know, I should like rewind and watch my own stream before proceeding with the stream, so I remind myself to do these things. All right, so I'm gonna go ahead and wire now a ground cable just like we did with the anode to the cathode. That way we are done with the soldering iron, at least for now, and then I can bust out the heat gun and do this heat shrink tubing thing there. So, is it already 3:53? Wow. We're doing well, guys. Yeah, I've been having a lot of fun. So, yes, we are. I got too excited there. So I'm going to go ahead and do the same and cut the little end off this guy. And we did such a good job the second time trimming this that I'm going to do the same. And I like to save these little noggins. They always, they always come in handy. So I'm going to do the same thing. I'm going to over strip like I always do. And, just a little bit of a wiggle wiggle. Not too crazy like I went last time. And that's pretty good. It doesn't look like I got too many strands. Because that's the worst. You make a nice clean cut, but if you cut too many strands, it does affect your signal flow. And then you wonder why things aren't working. And it's not at all how you hook them up. It's just sometimes a simple thing like that will jack things up. All right. Robert says, magic 8-ball skills. Yeah, no, I need to develop that. I need some kind of magic 8-ball. And then Hayes has joined us. I can't teach my wife how to solder. Oldest daughter, I still have her first practice connection. Wonderful. Hence the Back to the Future shirt says pinball. Of course, yes, I'm not following my own movie advice right here. But yes, learning to solder, I think for a lot of people, because of the heat, I know for me, when I started, I'd be very like pinkies extended, like I would have an English cup of tea because I'd be afraid of burning myself. But honestly, I've burnt myself. It's bad, but not bad, once you do it. So I'm going to do the same thing, and it is much easier oftentimes when you cut, your leads, because working with long leads can sometimes be a bit much, but I'm leaving everything pretty long here. It doesn't really bother me. So I'm going to do the same, and basically I'm making an X shape, if you can see that, and maybe I can, and of course, move this. Oh, the trick is now finding where I gotta put it. There we go. So I'm making an X shape like this, right? And then all I'm going to do is bend it down and then just twist it around. Make a nice little, that just makes a connection that holds itself together, and all that does is make it way easier for us to solder. So I'm just taking this strand and wrapping it around, and you can see, how that is, and then I can just do that. Although doing it the other way would have been better. I'm trying to do it for the camera, and oftentimes you end up doing it opposite. For you guys, it looks right, but for me, it's not. So I'm going to do the same thing, but start the X differently. And that's the toughest part sometimes, is you want to make things that are easy for you to see, but then you guys can't see it. And then when you do it the opposite, then you guys see everything perfectly, and we're sitting here blind trying to get it. So here I am winding the wire around just like I did with the, oh, it came off. All right, to wind it tighter. It just does not want to be on its date and get to know the resistor. And the resistor, it doesn't matter what lead you put where. You can wire it like this. I could have turned it around, wired it the other way. It's fine. All right, so very lightly, I'm moving away, and you can see that it's wound, and I'm gonna get with the soldering, so I'm just gonna back this up a little bit so you guys can see all the soldering glory that's going on. Very slowly do this on right there. And I'm gonna move in actually, because the camera is having trouble focusing on the joint. It wants to focus on my magnifying glass, so I'm going to move that magnifying glass out of the way so you guys can actually see the joint. And if I put my finger there, maybe it'll trick itself. Let me do that. Oh, there we go. I got it to just manual focus. All right, so we're going to keep it there just to make it happy for now. And let me bring back my fine leopard print. We're gonna go ahead and just cleaning here. Nice shiny tip. And I'm gonna stretch this out this time. Get it. Dump the excess. And I'm gonna do the same thing. I'm just gonna hold it under the joint, let it heat up the joint. And this tip is a little bit big for this job, but it's the one I was using for another project. So there we go. Clean, 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 Mr. Clean. Oh guys, I did it again, didn't I? A 2 for 1. Did I not forget to put the heat shrink on? I did it again. Oops, I did it again. I'm bringing that song back. Let me move this out of the way. Lame. But hopefully I'll be rewarded again. If I was rewarded once, I could probably be rewarded again. So we have a couple people joining us, and we're getting a couple questions. Well, Joe is saying that just to let me know, he's in the process of calling the fire department for me, just in case. I've dialed 9-10 digits just to be, okay, well, thank you, because you never know, I'm gonna need it. And then Hayes is asking what I'm making or repairing, and then Robert is laughing, hopefully with me and not at me, although at me is fine. Main Gun is asking, what's the value of the resistor? 220 ohms, 220 ohms. So getting back to some of you that are joining us for the first time here, we are making a fart detection machine. And right now I am wiring up the LED eyeballs that go to it. So the red eyeball that will illuminate once, it detects a bad fart, and we'll wire up the yellow ones and the green ones as well, and then each set will go into our puppet here, which will then go into our actual stuffed animal, and his lights will light up the different colors depending on how bad the fart is. And also we have a servo to move his nose like that, so hopefully he'll look legit and not like all like contorted once I get him going. So if Pinball says, I'm an old school, never seen a tip cleaner like that, always use the dampened sponge technique. Yeah, and the dampened sponge works just as good. Here, I got mine. I always, after years of using the brass, I always wet the sponge and keep it like as a backup. I don't know, it's like an old safety blanket that I keep around. So yes, the sponge is there. The brass just cleans so much faster and so much neater, so I do really like that. So I think we are done with soldering for this one, and I'm going to heat shrink tube all this stuff. It's a verb, heat shrink tube. So I'm going to unplug the soldering iron here and move this aside for now, or put it right back where it was. I thought I was going to move it aside, but I'm not. And I'm going to go get the heat gun. So I'm going to disappear for a while. You know what? I'll put you guys on a quick intermission. This is literally going to be less than 30 seconds. I'll be right back. But there could be some noise that you might hear. So, mute. And we are back. Child labor laws might apply. Well, Joe, he's all being truthful and stuff and raining on my, sweatshop child idea parade. I'm just down here. Don't mind me. I'm just down here plugging in my heat gun right here. So yes, I had made a comment that we do need children with 4-year-old little hands to work with these tiny, tiny electronics, and he's calling me out on my child labor laws. Yes, you do have a point there. All right, I'm gonna bring this on back here. And I've always liked doing heat shrink tubing. It's just very relaxing. So let me try and get this in a place that just moving the camera around that you guys can kind of have a better view. And also I can work, because that's just the worst. Moving things out of the way. Way too much going on this table. So, there we go. There. And I'm going to put my finger here and see if the camera focuses. Oh, it wants to focus. There it goes. So, yeah, I talk quietly to it. Let me see if I start messing around with it. I'm going to put the heat shrink all the way up. There we go. I'm going to fire it up. Oh, it's all tangled up on me. 1 second. There we go, I'm back. It's starting to think about it. I hope this is a 2-to-1 shrink and not one of those that don't shrink really well, because I did kind of pick a bigger size in order to kind of go over that female connection, because I had forgotten to do this before, but it looks like we're okay. And I'm using low heat, so it does take a little while longer. I'm just gonna get up and just kind of dial down this fan. There we go. It got much quieter. All right, so that should be pretty good there with our heat shrink tubing. And I'm gonna do the black one as well. And this time I'm gonna try and focus this just a little bit better for you guys. It's just freaking out, doesn't know where to pay attention. Kind of like my brain sometimes. Just don't know where to look. And that, go to your home. I'm just gonna release the hounds here for a second, because it is getting caught up on something. Oh, it's getting caught up on the old tube. There we go. And I actually do not need you anymore. I'm gonna do that. And heat shrink. Actually, this one's not long enough. Let me go get a much longer one. I was so paying attention to the focus that I didn't even pre-measure. And that's what happens a lot of times when you do not cut your leads. You should probably cut them a little bit shorter. So let's see if I can still get this off. There we go. I will be right back with a much better, longer heat shrink tubing option. So 10 seconds. All right, I am back with more options. And let's see. Main Gun saying the nice thing about using child labor is that they work for chocolate chip cookies. That is so true. You can just have some ice cream and popsicle sticks and say, here you go. So I just got this new kit here, because I started running out of the heat shrink tubing that a lot of these wiring kits come with, so I usually like to use them first before tapping into the good stuff. And then I have a roll of really good stuff, but it's way too fat for this project. We need something a little bit, I don't know, maybe something like this. Where is it? Oh, here it is. So let me see. The trick is that I gotta get it through this. Ooh. And the resistor. So this might be a little bit too tight. Maybe this one? Yes. So I'm in between this one and this one. still a little too tight. I like it, but this is just first date. You don't have to be so huggy and clingy. All right. And I'm going to put that all the way. It's getting caught on something. All right. So, same deal. We're going to go through it again. So that's what we have. We have our power all wired up, and we have our ground wired up with our 220 ohm resistor. And the idea is that I basically would go through my box of LEDs and wire up in the exact same fashion. Another red one, 2 of these yellow ones, and then 2 of the green ones right here. So after that, you can see that each of them has a pin, and they would just connect it directly to the Arduino. So if we have this little guy here, and I'll put him kind of in view and back, whoop, the other way, back us up, and we might get a little bit of a shaky vision there as I mess with the camera and move all this stuff. Please tell me I'm not the only one that has like a work surface that's just this crazy. So I'm going to put this guy here. So if we have, of course, our power facing down, because I'm thinking I'm going to put where its legs are right here, some kind of power battery supply that I'm going to hide it in the leg of our FART-A-TUCHUS. So we have our red LED, and it's basically going to live inside here along with a yellow and a green one. So they're all going to get shoved in like that. So it looks like, oh dear, come here, tail. So you can see it there, see? So imagine having a yellow and a green one wired in this exact same manner. And this guy will be like this. So once our LED is inside the eye socket, and I'll just kind of keep them like this, all we're gonna do is plug the red, because this is red, I'm going to plug it into the port number 13, just like we had in our code. But because we're going to do 2 reds, I'm going to have to change the code a little bit and add a couple more LEDs, 3 more LEDs. And this ground, I do have this pin, but I'll probably end up cutting it off. And what I'm going to do is tie all these grounds together from the LEDs and have it go to the common ground on the board there. So you have everybody grounded. Because these are powered differently depending on the scenario, they don't get connected together. They go into each of their pins. So it wasn't super necessary to do this. If we're wiring up multiple LEDs, if you're only wiring up one LED, this is a perfect way to do it. And then you would just stick this into ground, and then you're done your project. So basically, multiple LEDs, they would take up all these pins here, or as many as you need. All these get tied to a common ground with your little resistor there. And that's how you would hook this up. The sensor too, we have the sensor coming from the tail here. And if we were to finish weaving this thing, it's also going to come up to our board here, in which the orange one is going to connect to our A5 pin, and red to power, of course, to the 5-volt power, and then the orange, which is our signal wire, to the analog pin, ground to ground. And you can tie all the grounds together for your projects and stick it into the main ground. Same thing for the power, so that way you don't run out of pins. The servo is the only thing that's going to be a little bit different. The orange signal wire for the servo here is going to come into the board, and the orange wire is going to plug into pin number 9, because that's how it's getting its input. Like, what do I have to do? Like, if it's yellow, what do I do? If it's red? But the power and the ground are actually going to get wired to a totally separate battery. And I have a case for 4 AA batteries, and that's what's going to drive the servo. It's one of the most popular way people drive their servos, because you don't want to drive the servo off your board like we previously did, just for testing purposes, but for real live production purposes, you want your servo to have its own power source. So the only thing that the board will be supplying power to are the LEDs and the sensor. That's it. And it'll be giving signal to everybody, but this little guy is going to be powered by himself. Now, my battery casing did not come in today, but I didn't want to push the stream off to another day, just, over battery casing, so I can show you how I would wire it anyways. Here's what I use for 9 volts right here, and it's pretty familiar. We've seen things, like this before, and you would hook your 9-volt battery in here, and there's a power and a ground. So if we pretend that this is my 4 AA battery casing right here on this end, it'll still have these 2 same wires. So the way I would wire the servo is have this end right here go into the Arduino. Obviously, this is our signal wire or control wire, so that has to go to the Arduino, leaving me the power and the ground. So what happens here is I'm going to chop these noggins off right here and match up red to red and black to black, or brown to black in this case, and that'll hook up to the battery, and that's what's going to power our servo. But I don't have that today, so our servo is going to remain powerless for now, and I'm going to continue the LEDs and the tail, and you guys can kind of see where this is going. And we have a couple more comments. So KFH says, mine is always messy, so thank you. I am not the only one. Joe G, 3 o'clock your time. I always thought you were on the West Coast. No, I'm a East Coaster. East Coaster, yeah. Main Gun 07, I use 3-to-1 tubing. For whatever reason, the 3-to-1 has weather sealing glue. Can't find 2-to-1 that does. Interesting. I did not know that. So thank you guys all for joining. I'm actually going to hang out live and continue this wiring process. But for those of you that want to hang out and watch, that's awesome too. I always appreciate your commentary. These projects always go along faster when we have a little bit of fun, a little bit of comments and things. And again, for Wrench Army members, plans for this are going to be available after we stream the entire project at the end of the month. The prototype that we did, the plans for those are already available. And one thing I wanted to get your guys' opinion before we go is this scenario. So I need a way to extend the tail where I am not like physically, like people see me going like this. So one idea I came up with is some kind of lever like this, and I figured the lever would go on his leg, and when I do things with the leg, I manipulate the leg, it shoots this out. And one thing I came up with was just screwing it on like this, and it works really well, except the bolts just never tight down enough, and there's only so much you can do it before you start to really damage the popsicle sticks. So I've just been practicing, like you almost have to use a ratcheting motion to get it going, and see how the leg already is loose. Well, that never works. So let's see if I can get it. If I had it perhaps a dowel, and if I glue a dowel and a dowel, well, that would prevent this whole business, because it just needs to go like this, ratchet down, and see how it starts to go out towards you guys. I do it sideways, and then it just needs to do this. So my first attempt at this whole ratcheting thing didn't work because it's just too loosey-goosey, and no matter how much I sit there and tighten these bolts right here, it just unhinges. So one idea I could try is using a little bit of a dab of hot glue just to kind of keep things in place. I'm not putting tremendous pressure on this or anything like that, so it should hold tight. So some of you guys are Pennsylvania, Pinball's from Pennsylvania. Rob is from the East Coast here too. So yeah, we got some East Coasters here. So yes, if you guys in the comments have an idea for how to somehow get this going, this is attached at a fixed point right here. leaving this arm here movable, but it can't move this much because it does need to, you know, push down and push up, almost like a, you know, not exactly a pendulum, but something like that. Loctite. Pinball has the idea of Loctite. That's actually a pretty good idea, and that's probably the one I'm gonna go with, because I do kind of like this little idea here, rather than using dowels, because if you start gluing things together, then the glue cracks, and you know, well then this thing is gonna be like in there. So this is the one thing. We've done a lot of things that are like kind of permanent, kind of not, but this is the one thing that really needs to not break on us, because I for sure am not gonna like run over to people and stick the stuffed animal in their behinds. I'd rather just hold the stuffed animal and do it that way. Extendo this. So hopefully by the end stream, like the end of the month stream, I'll have this figured out, this lever situation here, but I will read all of your comments and see if you guys have a better idea. So far we have the Loctite idea there, and I'm going to use some of this electrical tape already and see if I can get this going. And my objective is just to get this kind of somewhat wired so we can test it out and see if the whole thing works, and then put the toothpick nose, you know, on it. So I've shown you towards the beginning of the stream the most important components of what we're doing, and so basically I'm taking what we've already done and repeating it out just to get it done. And oh, I put them all here, and now I forget how I had this structured. So we need a red, and we're going to do this, and then we have female to female, or male to male, in order to complete it. I think that's what we decided on. And if we didn't, well, that's what I'm deciding on right now. Dawn is saying, it'll work. So hopefully you're right, it will work. And Dawn, Main Gun 07 is saying nylon lock nut. Yes, that's one thing I could try. Istanbul, Turkey, 1970 Chevelle. Wow, good for you. That's a nice trip to be on. I'm here in the shop. It's less exciting. So I'm going to try and get this thing oriented so I can just go in all at the same time, which is totally working, those of you that are paying attention, as in not at all. There we go. All except one. And all the colors are right. Yes, I got it. And where am I? I'm going into here. So sometimes it's easy to zone out and then just wire it up all crazy, and then you're trying to figure out what the heck it is you were thinking. And weaving it through. We're gonna have some weird little humps, but oh, we got someone from Jersey. David Beck is saying throttle cable. Interesting. I'm liking that. I thought about some kind of retractable spring situation, but a throttle cable. I'll have to like find one on eBay and play around with that idea. I was either going to try that, Loctite, or hot glue gunning it like somebody else had suggested, or some kind of spring mechanism that retracts. But I am liking your throttle cable idea. I might have to steal it. Oh, we got someone from High Plains. Nothing here but cattle and coyote, which is nice this time of year. I love the snow. I know a lot of people don't, but if you bundle up enough, it's actually quite fun to walk in. It's my dog's favorite time of year. He doesn't tolerate the heat much. He's a Labrador Newfoundland mix. so he gets quite hot. But the cold, he is all about that. And because he's a mix, his fur's not even that long. You would think he'd be cold. He's got some, you know, more bare spots in his armpits and stuff. So you would think he'd get all cold. But nope. Oh, wait. I almost did it. Did you guys see? I was about to go in the wrong hole. Almost. And Robert is saying he loves snow too. And 1970 Chevelle 396 is saying he goes back to California on Friday. So I take it then you are from California. And Syed is saying, just joined. What are you making from London, UK? Awesome. So for those of you that are joining, I see some of you guys hopping in right now, joining the stream. So hey and welcome. So we are making a fart detector. I'm just gonna call it what it is. I can call it some very fancy names, but it is indeed a fart detector. And before I go on with that train of thought, I'm getting to a very important point in the build where you guys see right here, I don't have very much more to go to reach the Arduino board. So I'm thinking, do I already go female to female? Oh, that might be tight. That might be tight. I think I'm going to do one more round. And am I out? I might have to do this. I'm trying to keep the colors the same, which sometimes works, sometimes doesn't. Sometimes you just gotta, there we go. And back to answering what we're doing. So we are building a fart machine, and you see the part of the endoskeleton here. And what I'm doing is wiring up the tail. And this contraption is gonna go inside a stuffed animal, a little buffalo stuffed animal. And the tail is retractable, as you can see with this scissor lift style that I used. And you can extend it to your subject's derriere, and you can retract it. And it's got a little sensor on the tip. It's an MQ135 sensor. And once it senses, you know, a farty gas, then it'll illuminate LEDs depending on the level of the gas. If it's just okay gas, it'll illuminate yellow. If it's really bad, it illuminates red. And these LEDs are going to be the eyes of our stuffed animal, our stuffed buffalo animal here. So those are the features. It's got the LED eyes, it's got this extendo and retractable tail, and then the other feature it's going to have is a twitching nose via a servo that we wired up earlier. That will probably be the last thing we wire up for today, and we'll see if how that works. Oh, maybe I could have gotten away with well, I might have been able to do it. I might have some extra wire, because Lord knows I'm not going to go back through these holes winding up another wire. So I'm getting pretty good at this. Look at how fast I'm doing it. So we've done a lot of good things today. Nothing caught on fire yet. You know, we still got time, but we avoided you know, nothing grenaded. So that's all good. And those of you that joined us earlier, we got to see a working prototype of this. So we know everything works. Everything is coded correctly in the Arduino software, and we're all good. You know what? I think I'm going to avoid this little hole here, and I think I'm pretty good. And if you hear noises, my cats have opened the garage door and they are meowing because they are hungry. They're like, stop your wiring and come feed us. It's dinner time already. So I'm sure it's dinner time or getting to that point for you guys, although it's still a little bit early for dinner. But for those of us that are more mature, we like to eat early, right? The 5 o'clock eaters or the 4:30 early bird special eaters. Ain't nothing wrong with that. So I'm going to move this LED here out of the way, and you can see where I'm going to mount my board. We're getting awfully close. So what I'm going to do is use a female to female as I kind of look around for it. And the female of this orange wire is going to go ahead and connect to our pin number 9. And then these two wires I'm going to leave as is for now because they're going to go to the external power supply, which is not here yet. And that will be, you know, coming next week. So I'm going to leave that as is. And so I don't forget what I'm doing. Let me find the female to female here. And I'm going to prep it, basically. I'm going to find an orange. All I need is this orange one right here. And this is going to go from our orange wire, and then it's going to go into our pin number 9 of the Arduino once I put it up, and pin number 9 is right around here. So that's going to look like that, and I'm going to, you know, find a way to kind of pretty this up a little bit so that way it's not just doing that. So the tail, guys, it is wired. The whole tail is wired, and there's our sensor at the end. Those of you just joining us kind of wondering what the heck sensor I'm talking about. At 4:30, our main guy is saying everything at the Chinese buffet is fresh. That is true. Pinball is saying no more blaming the dog. So are you going to finish it next week by dawn? Yes, I'm going to be working throughout the week, and the idea is to then stream it not next weekend, but I think the weekend after. I think this coming weekend we're going to switch gears and do steampunk cabinet doors. I think that'll be a lot of fun, but then the week after that, this will all be done, and you can see what kind of fun I've had with it. So guys, let's see. No obstructions. Look, it closes all the way, opens all the way. So I think we have enough slack in this. So this is done, and all I have to do is wire up the LEDs for the eyes. We have one done right here. And I just gotta wash, rinse, repeat, you know, like that commercial. So that's that. And because I got a hungry 2 little fellas up there, I'm gonna get to feeding them. And you all saw how this goes together. So you can pretty much extrapolate how the rest of this is gonna go, and then plug it into the Arduino, which is gonna be on the back, which was decided by you guys. So I'm gonna do that, and I'm gonna try some of your ideas here and see which one works the best for this little lever situation to be able to extend the tail. And then finally this week, I will be getting this buffalo, and we're gonna try and put him in here. So I've already test fitted him. He does fit. I think I got the angle about right, you know, and that was probably the toughest part because I didn't measure any of this stuff out. So it was just to get his back angled properly with this. And of course, I'm going to purchase more fabric that is similar to texture like this, and it's going to go on the tail, and I'm going to maybe sew it to these top little eyelets is kind of the working theory of the idea. And so of course I'm going to sew it when it's all the way out like this. So it's got all its slack that it needs, and then when it contracts, the tail will contract. Maybe I'll do a poofy kind of black ended tail right here just to kind of conceal this sensor just a little bit so people are not like, what's that shiny thing on the end of his tail? And yeah, and theoretically, if all goes well and nothing catches on fire or grenades, we should be seeing this project here shortly inside his little costume right here. So I think this is super, super exciting. I'm excited about it. I'm excited to try it out on unsuspecting suspects. So thank you guys so much for joining me today. I always have fun when you guys join. You always have great ideas. Sometimes it's nice to borrow ideas, and you know, and that's fancy for stealing your ideas. And because it's sometimes you are too in the weeds with your project, and it's nice to have people that are kind of taking that 50-foot view and saying, hey, this is a much better way of connecting it. And you guys see the final result. I do implement a lot of your ideas. So thanks so much for joining. My name is Rachel DeBarros, and you have been watching Gearhead Diva. Check out the Wrench Army for bonus videos and project plans for all of this. See you guys, and have a great rest of the weekend. See you.